Hi, I'm Martin Lindquist. I'm a professor of biostatistics here at Johns Hopkins Bloomberg School of Public Health. And I've been at Hopkins for now 13 years, so 2012. It's gone very quickly. Previously, I was at the Department of Statistics at Columbia University for 10 years, and it was time for a change, and I'd been here, giving a seminar, and I was sort of really impressed by the sort of warmth and collegiality of the department, and it was something that I was really sort of seeking. I applied for a position here, and was lucky enough to come, and it's been fantastic. Yeah. Well, I've always been sort of mathematically oriented and things like that, but I've also been extremely interested in solving health problems and societally good kind of things, and biostatistics was always sort of a nice sort of common ground between sort of the sort of mathematical skills and sort of the wants of doing sort of public health and helping with diseases and things like that. Primarily, I work with statistical methods in functional magnetic resonance imaging. So we look at scans of your brain over time. So we basically get a scan of your brain every second or so, and then we can look at sort of changes in sort of the oxygen patterns over time, and that's sort of linked to your neuronal firing. So you can sort of see where in the brain is working over time while you perform certain sort of tasks. So and then you can figure out sort of how the brain is sort of communicating with each other, and then you can sort of look for kind of how it communicates differently if you have a disorder or a disease and things like that. So that's what we work a lot on. Well, I hope it gets used in clinical settings. So we've done a lot of work in the pain world, and so we've developed sort of biomarkers for physical pain. So we can, there's basically two ways of seeing how much pain a person is. One is asking them, and the other is we can look at your brain activation, and also be able to sort of predict how much pain you're feeling. And so now we're trying to extend that to look at chronic pain, and so we're collecting data on almost 3,000 people who are about to have a surgery, so an intervention, and so we're trying to look and see if we can look at their brain and their omics data and how they relate to each other, and if we can tell who's going to wind up having pain 6 months later, which is chronic pain, and that actually happens more often than we'd like, right? So for some surgeries, can be like 25-30% of people have sort of long-standing pain at their surgery site, and if we can sort of spot that earlier, we might be able to sort of intervene and help them, or maybe recommend against certain treatments that could cause long-term pain. Well, we're working a lot on these chronic pain things, so I think we're going to be working a lot in sort of combining sort of brain imaging with sort of proteomics and metabolomics and sort of SNP data, DNA type data, and health records, and sort of combining it to sort of figure out, can we create sort of signatures for people who are at risk for chronic pain when they get surgery or not. And so I think that's going to be kind of the big area that we're working on. But we'll also continue working on sort of developing new methods in fMRI. It's going to be those two paths, I think, is the next couple of years. Yeah. It's a very warm and fun environment. It's fun to go to work. People are always sort of joking around. They're serious. People are great. They do great work. They take their jobs really seriously, but they also are always willing to sort of help you out and be a support for you. And I think that's extremely valuable. Yeah, I teach classes. I teach actually the first PhD class that the students take is this method sequence. It's called for first year PhDs. So I teach sort of linear models, and so I get to know all first year PhD students as they come in, and it's great to see them, as they progress through the program. Yeah.